get into speed. Yeah, fine. There is something called MapReduce types. You'll have to understand what MapReduce types is. When you say MapReduce types, you have something called, this is something you would have already learned. So you, when the mapping process, you have input key value pair and you create a list of key value pairs. So that would be used by the reducer to get the desired output. That is what we call it as a. So when you say like input key value pairs, so the initial, your mapper input should be a key value pair and the output of your mapper will always be the key value pair. So on the reduce side, the reduce input should always be the key value pair because the output of mapper only would be used as an input for reducer. So that the reducer input will also be a key value pair and your reducer output might not really be key value pair because it is something in our hand. We can actually emit in the way whatever we want to actually do. So but the fact is like your mapper's output and your reducer input will always be key value pair. So that is what we call it as intermediate key value pair. So the output is always in our hand to actually format that or emit that in whatever way we want. So yes, so if we actually use a combine function, this is how like it will work out. So when you say you use a combine function, later after your map function, you have a combine function. Your combine function does that locally within every mapper, and this would be actually used by a reducer to reduce it on a higher picture. So combiners are all nothing but local aggregators available within your mapper function itself. So that is what you call it as combiners. So combiner is actually primarily focused on getting your whole data more optimized. Lesser intermediate data is what the whole goal is all about. And you have something called partitions. So there's a partition function that actually works on the intermediate key value pairs and returns a partition index. So here a partition is primarily like not really is required to understand explicitly, but just understand what partition is. Partition makes sure that I said something called the output of all your intermediate key value pairs will actually go into something called reducers, right? So but not split across the key value group, but across the whole picture. So which means the first half of the key value pair groups would actually go to the first reducer and the later half will go to the second reducer, right? In that way, like how does a partition work out, or even after the sorting process, or how does the group keys are all getting grouped and partitioned together or partitioned together. So that is how that is what the partition function will work out on. So this partition function will make sure that all your keys grouped by your all your key value pairs grouped by your keys actually go into one single reducer. So that is the actual function of your partition. So your partition function will be in the backend behind the scenes to actually do that work. So that is what you call it as partition function. You just need to understand that these are all few functions that is all working behind the scene to actually enable you to get things done. So let's understand shuffle and sort today. So we'll actually finish off with shuffle and sort. This being, any other questions on topics that we have seen till now? Your phones are already unmuted. Any other questions? Yeah, perfect. So we'll get started with the next topic. Basically, let's understand what shuffle and sort. We would have already and sort is. So basically this map reduce makes a whole guarantee that input to every reducer is sorted by the key. But essentially how does that works out? Basically this is all because of some function called shuffle and sort. The process by which the whole system performs the sort and then transforms the mapper output to reducer as input. This is what we call it as shuffle. This shuffle is a primary place where the whole magic of MapReduce actually happens. So this is what the whole funda behind Shuffle, and this actually plays a very major role. So it is actually primarily meant to optimize and also to actually improve the whole. It actually remains the heart of the whole MapReduce programming, because without shuffle and sort you would have already seen, we have already seen a scenario without shuffle and sort what might be the output. So that is all some kind of junk output that does not really make sense. So that is what the shuffle. So on the map side, there are few things that we'll need to understand. So in the map side, it actually in the mapper side, what essentially happens is it actually starts producing the output, which is nothing but the intermediate key value pairs that will be written into the local disk. So when you say the local disk, which means local disk of the data node where your mapper function is all getting executed. So that is what you call it as map side execution. So when you take that example, so it actually writes that into the local disk and leaves it behind. So in the reducer, your reducer is something that is going to sit in the local disk of the machine that ran the map task, that will all collect all those mapper tasks, that is the output of all your mapper tasks together, and it will be actually keeping that. So this is what you call it as copy phase. Let's understand that. So when you say you have some 20 mappers, you still have reducers like idle, so which means there is nothing called reducer task that is all happening. So in that sense, how does your reduce function will actually use will be utilized? So basically when you say all your mapper functions have created or written some output data, so that output data is available inside your local disk. So that local disk, how that local disk is all being actually read? So that local disk, the local data written by your mapper function will be read by something called the copy phase of your reduce task. Your copy phase of your reduce task will randomly collect all the output data that is all created by several mappers then and there. So it will all be collecting that together, and once all the mappers has been completed, so this data will be used by your shuffle and sort, and this will be sorted, and then your reducer would be actually given, then your output is all being processed. So that is what we call it as that. These are all some key things that is all happening in the back behind the scenes when your mapper is all running, and your reducer is not just idle. Reducer is now will be in the copy phase of that task, so where it will be collecting all the data that would be actually produced by your map. So when you say that, okay, like I said, some random value, random time at which your reducer comes and collects that out. So when you say that, so basically these are all mappers. The leftmost example, the leftmost tire actually explains to you the number of mappers. After the four mappers, you actually collect the output data of those four mappers and keep it. Later, the round two, like you actually collect the collect the data produced by some around 12 mappers. So that is what the output that would be collected and kept it. So similarly, round three and round four. And once you actually get all your mappers completed, you have something called the whole data that is all available as a chunk of data. Use that data to actually this data would be readily available to for your shuffle and sort to work out, and then your reducer will process that. So that is how the funda is. So there are few performance tuning options that you will have to actually learn. Basically, when you think about memory, yes, Hadoop is primarily we need to focus on the RAM, that is nothing but your memory. So that will actually improve your whole processing. At least for reducer, you need to give higher memory. And for mappers, so there are few performance optimization techniques we need to understand. So there is a way to actually optimize your JVM. JVM is a Java virtual machine. So to improve the performance of increase the heap size of it. So heap size is nothing but your Java virtual machine's memory size. So that will actually improve your whole performance of your Java. So that is what we call it as your heap. That is one thing. And to actually tune up on the map side, so you have few options to actually do that. So when you say map size, you have something called 64 MB of block data, right? So this are I'm getting into even deeper. Just understand some key concepts that is all quite relevant to understand. So because when you say like your HDFS data block size, the default size is 64 MB, the 64 MB will not really be loaded right away into the memory. So it will be actually loaded, like it is more of a paging concept. So not a one file would be literally loaded totally. So because you have something called cache, your cache might not really be more than 8 MB or 6 MB in most of the machines. So in that way, like how essentially does that going to work out? So when you say that 164 MB file, even though it is already a chunky data, but in that data node or task tracker that needs to process that 64 MB of data, it would be actually picking a part of the data and process that, and later part of the data would be picked up and then processed. This process of actually reading and writing the data inside and outside your RAM, so that is what you call it as spill to the disk. So because you actually read from the disk the data and move it into the memory and process that and write back to the disk. So this multiple spill to disk should be avoided. So if you say like it is 64 MB and your machine is good enough to actually handle a more larger data set, rather than by default when you actually have the configuration to be actually 4 MB, which means 64 MB, like 4 into 16, which gives you 64 MB. So that will not really be the case. So in that sense, we need to understand something like your 4 MB should be actually increased to at least some 10 MB. So in that way, like if you use 4 MB as the actual IOSR dot value, so you will be doing something called multiple spill to disk, which means 16 times you will have to do spill to disk. So that can be actually reduced by increasing your IO.sort dot property. So this will actually, when you increase that sort.mb value, so if you can specify that as 20 MB, so when you say 64 MB of like block size, you can actually do it in some 3 to 4 times rather than 16 times, which will actually improve your whole performance. So this is what you call it as, this is one primary way of actually optimizing it on the side. What essentially happens is, so when you say reduce side is going to work out on the whole larger data set that is all being created by several mappers, right? So in that sense, reduce surely requires a bigger memory. So when you say like larger memory, because when you deal with large amount of data, you need to actually process it on the whole. So that way, like if you can actually have more memory, that would actually still improve the whole performance of your map reduce task. So that is what your reduce side tuning is primarily. And there is something called merging. So this is merging is nothing but like you are collecting from a lot of data and then you need to merge it and then load it into the memory. If you can also improve that, that will also be fine. So these are all few things that you'll need to understand, because when you say Hadoop or any MapReduce job, there is no standard optimization technique, but there are few things that you can actually optimize literally right away. So but on the initial stages. Hello, for the delay. Perfect. Questions on this? Sorry, go ahead. Which one? Okay, the optimization of your reducer. Okay, fine. Okay. So when you say a reducer, you essentially have something called, when you say reducer, what is the whole funda behind reducer? So even before the later class, understand why reducer is more important here, because reducer is going to deal with the larger data set, correct? Reducer is going to deal with a larger dataset, while mappers would be dealing with smaller sets of datasets. While reducer has a responsibility to process all the data and derive at the desired output that anyone wants. So in that way, like reducer needs to collect all the data and process it on the whole picture. So in that way, like your reduce will really require higher memory, because most of the data should actually reside in memory itself. That is how it will actually improve the performance of your reducer. These are all some kind of tuning options that we need to actually make sure to get things ready. This answers your question. Basically, this reducer tuning says you need to have more memory. Memory is a thing for reducer. No, no, no. It's all depends on like how you are actually going to set things up. Basically, it is not the reducer. You can actually still configure it over the configuration options. Your mappers and reducers are all by default based on the configuration. Your Hadoop configuration, your number of mappers and reducers will be already by default picked up. Otherwise, like it is not really required for reducer to actually be explicitly specified. No, 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 not for reducer. But essentially, there is some way actually to do. But primarily, it is more relevant in mappers because mappers is where like you do a lot of processing, while reducer you actually collect all the data and aggregate things up. So that way, like memory itself, because when that itself will go out, right? When you say you have more memory, that kind of spill to disk concept will be coming as a secondary picture. If you have more memory, that will not really come into picture upfront.
Hey, Saranath, this is Harish.
Yeah, yeah.
Yeah, I have a quick question actually. In terms of the mapper and the reducer, right? So I think in one of the last classes
Okay.
you have told that there can be only one map reduce program running the whole cluster, right? In a sample cluster of three data
Yeah, yeah,
nodes and
right.
one master. Right? So when this mapper gets initiated,
At any point of
uh,
time, one cluster is meant to run one MapReduce program, right?
can you come again? Okay, so let us say we have three compute nodes and one master node, and
Okay.
uh, and I initiated two MapReduce programs. One I forced it to go to only one data node, and the other one is
No,
executing on.
that's not possible. That is what that itself is wrong. When you say like you can't really initiate two MapReduce programs on a cluster. At any point, only one MapReduce program can run in one cluster.
Even though the cluster is of 100 nodes or 200 nodes, or it doesn't matter. Only one job.
Like it does not really matter. Basically, like when you say there is one master, right? One master can handle only one node at one job at one single point. If you want the
Okay.
two jobs, okay, finish that first job and then do give the second job. So
Okay.
this kind of questions, there is something called workflow engine called Uzi that will give you a picture on of okay, because there is one job and this job needs to execute after this job.
Okay. Got it.
How do
So
you
my
do that? There
question
is
now,
something called workflow engine in Hadoop system. That is what you call it as Uzi.
sure.
Okay.
Thanks.
So, yeah.
Yeah. So my
Yeah.
question now is, okay, now that we know there is only one job at any given point because it's only master node is tracking only this job. So when you run this MapReduce, the thing what you're talking about, like based on the configuration. So is this configuration something like a header file for each MapReduce specific
It
application?
is more of XML data where like you have something called configuration files. Most of the data would be picked up by default. Otherwise, there are few configuration options we need to explicitly specify. The other details like everything is all already available inbuilt.
Okay. So the
Okay.
question,
So
so when okay, so when you change the configuration file, right? Okay, now
okay.
will it apply to the whole cluster, or because the
In
way I
fact,
want to
yes.
do is, yeah. So
In
the
fact,
way I
yes.
want to do
So
is I want to run. uh,
go ahead. Yeah.
Yeah, yeah. So the way I want to do is, okay, I have a MapReduce program one. I need that to take this application profile where I want to improve the performance by increasing the cache from 4 to 6. And I have another MapReduce program which is coming down the lane, which will take a
Okay.
different configuration. So in terms
Perfect.
of the
Yes.
application in the MapReduce, can I specify this as a header file
Yes.
configuration specific to the
You are right.
application?
We can configure
Okay.
that. So that is where your actual reason behind configuration files are all there, because it is not just one configuration where even in your programming stuff you can actually specify your number of mappers and reducers. So that is also is available. So more than anything else, you just need to understand what understood is right. The configurations is all also meant to actually change your number of, because it can still be done on the configuration data. Do you convert Shivraj question like, so this XML data is like nothing but a configuration. This is nothing but like when you have a web server, you will have a file, right? So that file will say, okay, the default port is 80 and this is a user. You will have to, similarly, any service that you run, it will have something called a configuration file. Similarly, Hadoop will have the configuration files that is all represented in terms of XML. So there is nothing with the data type input that we saw as XML with to be confused with this. No, because it's quite early, because we'll be seeing the cluster setup in the few in very closer sessions. So that way, like you'll be getting an even clear picture. Yeah. Otherwise, XML data that is not XML data. It's a XML file to actually store the configuration. Make sense, Harish?
Yeah,
Got it?
got it, sir. Thank you.
So
So,
in every mesh can still be configured that this much number of mappers needs to be actually handled, because when you say Hadoop, it is a mix of heterogeneous data nodes, right? So in that way, like some data nodes would be 16 GB RAM, some data nodes might be 4 GB RAM. So there is nothing called general configuration that will work out for each and every machine. So if you are actually going for generic configuration, either you will be actually overusing some resources or underutilizing some resources. So that is the reason why in Hadoop there is a standard way called non-central configuration. So there is nothing called a central configuration option. So each and every machine you can configure it accordingly to its own configuration. So its own features. When you say 16 GB RAM machine, you can actually process some 20 mappers, while 4 GB RAM machine that can just handle some 4 mappers. So when you configuration, you can't really actually run 10 mappers on your 4 GB RAM machine, while that machine can the 16 GB RAM machine might still be running five mappers. So that way, like that will not really work out, right? So that is what you call it as non-central configuration in Hadoop, where each and every node you can actually configure things up based on your own requirement.
so Salma, I have a question here. This is Harish.
Yeah, go ahead. Yes.
Yeah. So I think you brought up a very good point. So we all know that data node can be of any configuration, right? Some memory
Okay.
can be 12 GB, some can be 4 GB, right? So
Okay. Okay.
initially, what is the recommended way of? I'm asking the same question which you have already answered earlier in the
Okay.
classes,
Okay.
but
Okay.
but
Okay.
I'm
Okay.
doing a different deviation on this one. So
Yeah. Yeah. Yeah.
we
Go
have
ahead.
a cluster, right? We have a cluster. So
Okay.
let us say somebody is implementing a production like scenario, and there is a cluster, and they brought in all this commodity hardware, which is pretty much of the
Okay.
same. Is it recommended to all of them to be of the same configuration, or because if it is the same
No.
configuration, you can
Basically,
deploy the
basically,
changes easily?
Hadoop was managed, or Hadoop was uh, planned in terms of actually such kind of deviations, to handle such deviations, because when you say like Hadoop does not actually impose any hardware restrictions, so which means like
Right.
when you say hardware restrictions, when you deal with hardware restrictions, you don't really need to actually say like whatever be the hardware that is all already available, you can just pick that up and then use it. So when you say later point of time you are actually getting few set of new hardware, your Hadoop framework should be in a position to handle that and accept that also. So there is nothing called okay, this is what the same standard of machine you need to actually work out. No, because Hadoop itself was meant for that.
Okay. So, hello.
Yeah, go ahead. Sorry.
Yeah. So in that case, right? Okay. Now I have different configurations across different data nodes,
Okay.
right? Because I'm editing the configuration file on the data which only has 4 gig memory, some other thing which is having 5 gig
Yes.
memory, right? But I want to optimize the whole
Yeah.
thing, the whole MapReduce job in a given, because it's running 3 hours. I want to optimize that
Yeah.
to 2 hours. How can I debug that this is the optimal configuration for this kind of a hardware specific or a memory
Okay.
specific on this
You
node?
will be on your
Is
own to
there any
actually answer this.
debug?
Basically, like you can, there are ways to derive that. There is also a
Okay.
formula to understand how many number of mappers you have to. That's pretty simple. Just have a thought process on it. Next session will be actually covering that up. Basically, these are all some techniques you will have to actually understand literally right away to understand that how many
Okay.
number of mappers is all required. How do you are going to actually load that in your Hadoop system and how it is all getting executed. Those details and all is all already available. So basically, when you say how many number of mappers for any function, any MapReduce job, how to find how many number of mappers? Any idea, everyone? Where is the control panel? No, like literally just I'm giving you a MapReduce job and I'm giving you the an input data set. So how can you actually exactly what Edward says? It depends upon the data, right? So basically when you say it's all the data will be actually split across into several chunks of smaller data, that is 64 MBs of data, correct? So which means each and every data HDFS block is mapped to one mapper, right? Your number of mappers, your number of mapping functions is equal to the number of HDFS blocks you have, correct? Got it? Edward, you meant that, right? So you're right. So that's a direct way where you can actually find, okay, how many number of mapping functions is all required to process this. That is one thing. And the next thing is, okay, how big your cluster should be. Like when you say 5 data nodes, you can still specify one data node to handle this much number of mappers. So those are all something that it is all available. So we'll have that discussion later after setting up the cluster. So that should actually give you an even bigger picture of that. Harish?
Uh, yes, Saruna. Yeah, I
Yeah,
got it. I think, yeah, it answers my question at this point, but I think, as we go more and
yeah,
start to
and
see the
mostly
system
like
holistically.
finding the reducer is not really a direct way. Essentially, there is some. Yes, 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 and more than anything else, your picture on actually optimization does not really come upfront because that's called a standard optimize things because some optimizations for one MapReduce job will improve the performance while the same optimization blindly utilizing it for some other MapReduce job will degrade the performance. So these are all something we need to actually understand, and based on the MapReduce job only your optimization should also work out. But these are all some standard ways like increasing the memory and decreasing the spill to disk value. So that would be like increasing the spill to disk value would actually improve the whole performance. So these are all some standard ways, but there are even in-depth ways to actually there are thousands of job configuration options that is all available to explore.
Sure, thanks.
Yeah. Fine then. Any other questions? Okay. Yes, 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 because you have a generic word called task tracker. Data node, I said like your mappers will be executing. So your mappers will be executed by someone called task tracker. Task tracker is someone who actually resides with your data node itself. So the task tracker can change as a mapper and also basically the tasks are nothing but mappers